Welcome to Let's Make a Game Platformer, episode 24. In last episode, I have added player death to whenever it touches the enemy, and also added the concept of factions, which allow us to specify who is the enemy for which entities. Okay, in this episode, I'd like to add a new enemy, which is going to be, in addition to patrolling the platform it is on, it will also shoot at the enemies. And I've created a new bag with gun, ugly picture here, and something for the projectile towards the left and towards the right. Okay, so let's start off by creating a new prefab. So it's going to be a bag with gun. And it will use a model bag with gun. And everything else for the time being is going to be the same as for the bag. And now I'll also add a model for it. So model bag with gun. And the images are bag with gun right and bag with gun left. Right and bag with gun left. Okay, so let me create a new level with this enemy. So it's in prefabs levels. Let me copy an existing one. Call it something 5, and let me modify the sequence to be only that level, and I'll create a platform above the starting one. So it's gonna be 0, 1, 0, 1, 1, 0. Let's make it a couple of blocks wide. 2, 3, 4, 5. Maybe even more. That's where the enemy is going to be living. And then finally, we'll create a final platform. 9, 0, 0. And a couple blocks there. 10, 11 and 12. Okay, and the exit portal is gonna be at the second to last block. Okay, and I'll create here on the 5205 a bag with gun. Okay, camera bounce, that's fine, and player death. Probably should extend this to the right. Okay, so let's test this level and the new model. Okay, we have an enemy. Jump over and then we finish level. Okay, so we got that part covered. Now we have to add the behavior that the enemy is going to be firing. So for that we need to add a new behavior. Fire at enemy behavior. And it's going to be a type. Okay, so for that we need to start writing some tasks. So in the AI, we have movement. Let's do a combat AI. And let's add a task which is gonna first of all check if there is an enemy in range. Has enemy, well, maybe let's call it find enemy in range. And what it means, it was a success if there is an enemy in range, and failure if it's not. So let's do this. Let's add task to the end, make it easier to find it later on. And we want to use one that is using entity ref reference. Once again, I have to create a constructor with the parameters that we had there. And we have to implement the methods, the 3 methods: starting task, continuing task, and canceling task. This is going to be a very simple one, so the continue task is never going to be called because start task will be able to immediately say, okay, there's an enemy there. So, as you may remember from the previous episode, enemy is something that is defined by the faction system. So let's now modify it here, and let's create an interface that which will expose a functionality of finding enemies to other systems like the AI. So in here, I'll create a interface called Faction Manager with, at the moment, one method, find closest enemy. And we'll specify here faction, or maybe not faction, entity ref, and location in only X and Y coordinates because we are working on 2D at the moment. Okay, so we want to be able to pass this information, and we also want to, because we are interested only in entities that are in front of the enemy, because, well, the gun is pointing to the front. We don't want it. We might later do that. It will check everywhere and then turn around if needed, but this is something that we can do later on. At the moment, we just find something that is in front of the enemy, and if it's there, it's gonna shoot. So in here, we'll add a predicate for entity ref. Entity predicate. So this predicate will basically tell, does this caller of this method accept or not accept, does not accept the entity that it wants to return. So we try to find one that is closest to this position and is passing this test that is provided by this predicate here. Okay, so I want to now make the faction system implement the faction manager, and we have to share it to other systems. Okay, now I have to implement the method here. And to do that, I have to, first of all, get the enemies of the faction. Get enemies. They get faction. Let me check. Yeah, first of all, I have to retrieve the entity ref, get component faction member component. So check which faction the whoever is asking about enemies in range is which faction it belongs to. So faction member and faction member get faction name, so faction, and now we'll get enemies for this faction. So we know the enemies for whoever is asking for enemies. And then we will iterate through all the entities that have the function, through all function members. So we have to create here, initialize an index on all function members. Function members entities, member entities. Okay, and we want to make it into a field. Okay, so I'll iterate through all of them. And maybe I will not pass here the x and y. Instead, I will extract the location from the entity itself here, since I have to do it anyway. This system has to be aware of location anyway, so I'll get here a entity ref get component location component. So this is going to be a very naive and very non-performant algorithm here, because I'll go through all of them. There are better ways of doing this. For example, in case of 2D, you have quad trees. In case of 3D, you have oct trees, where you store all the positions, track all the positions of the function members, and then searching for the closest one is really, really simple. But for now, let's go with this float max value. And so in here, we'll have to check the function name. So let me extract this. Get function. And in here we can use same here, get function entity ref. So I don't have to have this here. And in here I'll also get function passing the function member entity. Other function. If enemies contains other function. So if this function of this function member that we have extracted from the all in the context is the enemy of this function, then we will be checking first of all if the predicate is passes. So and contains and the entity predicate test function member. So let's rename this other entity. So first of all, it has to be an enemy, and because it's a quick test, and the other entity is actually passing the predicate that was passed, so it's accepted by the entity that was asking about it. And if so, we'll be getting the location. Other entity get component location component other location. And now we have to calculate the distance of them between these two. Only in the XY coordinates. So it's going to be a square root of a, let's get here, float x location get x, float y location get y, and here load other x, other location, get x, other y, other location, get y. And calculate the distance. So we have x square is other x minus x multiplied by other y, but other x minus x. So this is basically the way of calculating distance between 2 points. There might be some other methods for it already, but other y minus y multiplied by other y minus y, and this is x square plus y square. Let me fix the typo here. So this is the distance. Unfortunately, this is in doubles, so we have to cast it. We don't need such big precision here. And if distance is less than lowest distance, then we'll specify that the result is the other entity. And here finally I'll return result. Okay, I just realized that actually I'm not interested in the closest enemy. I have to check if there is an enemy. So has enemy entity ref predicate. And I want to return boolean here. So I want to fire if there is an enemy I accept. I don't care which one is it. Okay, at least at this point. Okay, so I'll add one more method here. It's going to be much, much easier, because it's going to be just this part where we'll return true. Otherwise, we'll return false. And we don't need this part. So let me go through this method quickly. We get the function of this entity, check the enemies, extract the enemies of it, and then go through all the members that we see one by one. We check what faction each one belongs to. Well, first one belongs to, and check if it's an enemy and if it's accepted by the predicate here. And if so, we return immediately true. This is going to save us some time because we don't have to go through all of them. We just go through them until we find one that actually is accepted by this. That's why I want to avoid using this method. Okay, so find enemy in range. Well, so tasks are also injected with, should be also injected with all the systems here. So I should be specifying faction system, faction manager. However, it doesn't. Tasks do not get notified. Do not get notified about events. That's why we have to split the. That's why I had to split in the movement here the task from the actual system that is responding to the events. Okay, so let me get back to this task. So what I have to do is say if faction manager has enemy reference. And so in here, let me for now send a predicate that's going to be accepting everything. So accepting all the entities. But in a moment I'll reference get entity. In a moment I'll modify it to do something else, to check if the enemy is in front. But at first I want to see that this actually works. So if there is an enemy, we return success. Otherwise, I'll return failure, as I described earlier. The continue will never be called because we never return the running. and it's never going to be cancelled for the same reason. It only gets cancelled if you ever return continue. Okay, so this is the task we want to have, and if so if it has enemy, we have to create a new task, which is going to be attack task, which is going to extend abstract task, AI task, and we have left these three methods here. We'll have a constructor, here entity reference and a constructor now. Yeah, wrong order. Okay, so we have this task, and it's going to be the same for continue and cancel because we're going to be doing just one thing, and the thing we're going to be doing is get entity ref sending an event specifying perform attack. That's going to be the event. So in here I create an event, perform attack. We're just going to extend event. So the task will just send perform attack and return AI task success. We can later introduce that this perform attack will actually return a result. The way we had, for example, should entity move, will have a value in here passed, and then we can, based on the result of this event being sent out, we can send success or failure. For now, we just said success. Okay, so we have that, and then let's add some components. So first of all, attack. Let me think for a second how to name it. We want to fire a projectile. Attack projectile component, and it has to be an interface which extends component, and we'll have here a get projectile prefab. So it's going to be the name of the prefab of the projectile. It has to be spawned, and we'll have, as usual, float get translate x and float get translate y. Actually, maybe not translate. How did we call it in the spawn entity on overlap component? Distance x. Okay. So let's call it distance x and distance y. So this is where the projectile should be spawned based on the location of the entity that requested spawning it. Okay, so in here we'll have a combat system. Which we have to register, of course, with the profile gameplay. And receive event perform projectile attack, and we'll have here perform attack event entity that should be firing it, and also the entity has to have the attack projectile component. Okay, so in here what we have to do is we have to spawn the prefab. So we need prefab manager and we need entity manager. So attack projectile, get prefab manager, get prefab by name, projectile prefab, and then entity manager, create entity for the prefab, projectile, and we have to specify a new location component, so projectile create component, that's the name I was looking for, location component. And okay, so whoever is spawning it also has to have a location. And this is going to be called projectile location. And I will copy the Z from the location of the entity. However, the X and Y, I will add the distance. Projectile location, set X, attack projectile, get distance X plus location, get X, and the same for Y. Okay, and I'll have to save the changes to that I've done here. Okay, that should be it. There's one more thing. So we have to check if this entity by any chance has the facing direction component, and if it has, we have to switch the subtract rather than add the distance X. So let's do it quickly. So let's extract this distance X, and let's do if entity ref has component facing direction component. So we'll get entity ref get component facing direction component, get direction equals. So let's assume that right is the default one, because that's positive X. So if it's right, okay, right, different way. If it's not right, so if it's left, we will do distance equals minus distance. So we'll basically revert the distance. Okay, and that's it for this. Now I have to create a model and a prefab for the projectile. So let's start with a model. I will copy the bug. So it's going to be bug projectile. And I'll have here fire right and fire left. However, I want it to be a slightly smaller, so like half of the size of normal objects. And now I'll create the object, which is going to be I'll copy the bug once again and call it bug projectile. So we want to use model bug projectile, translate 0.25. That's because the model is the size of the model is now half. Sorry, this one. So we want the position to be in the middle of it. So half of that. It has to be moving. It should not be affected by gravity. We want to detect the collisions, and the size is width and height is half, and hitbox. Actually, we don't want it called collide. Oh no, we want it to collide because when it runs into a wall, we want it to disappear. Okay, so let's do the same here for the hitbox. We want to be able to rotate it, model on movement as well. AI component, we don't need AI on it. Face it direction is going to be right. Movement configuration, there is no AI on this. And faction member is going to be bug, yes. So this is an interesting one. So the projectile that is fired by the bug has the same enemies as the bug itself. So therefore we have here a bug faction here. Okay, and then we have to specify that the bug with gun has the attack projectile component. So this is a new component that the normal bug did not have. So the projectile prefab, and the name is bug projectile, and distance was distance, yes, distance X. Let's say it's going to fire it at 0.5, and also 0.5 from the bottom, because the origin of all the models that we at the moment have is like on the bottom in the middle. So that's what we want to do. Okay. So that's it. Now we have to create, at the moment this bug with gun is using the patrol endlessly, patrol endlessly behavior. So I have to create a new behavior now, fire at enemy, which is gonna be type sequence once again, and tasks will be, I think it's an array, yes, array of objects. So first of all, we want to check if find enemy in range, whether there are any enemies in range. We have to specify type here. Second thing to do, so if this one is successful, so if there is an enemy in range, we want to invoke the attack task. Okay. Now, so if we assign this behavior to our AI, the bug with gun, then it will just keep firing if there is an enemy. However, we want it to be able to also walk. So what we can do here is create a new behavior saying patrol and attack behavior. And in here, I will be creating a sequence. Of the following tasks. It has to be an array, and first task will be to walk endlessly. So I can import here. So this is another task type import, and I specify which file to load, so which behavior file to load. And I'll say I want to load the patrol endlessly. However, so as remember, this is endlessly, so it's never gonna finish. So we want to limit this to say So we will use a max length task for just sort of a decorator that we wrap the existing task. So we'll say that we want to execute this patrol endlessly, but only at maximum for the duration of 5 seconds, maybe 3 seconds, every 3 seconds. So it has to walk for 3 seconds, so the patrol the area it is on, patrol the area it is walking on for 3 seconds, and afterwards it has to check whether it can fire. So the way we do it is by import here once again, and behavior fire at enemy behavior. Okay, so this is what's going to happen. It's going to walk for 3 seconds in the patrolling manner, so it will turn back when it hits the edge or something that blocks its way, and then it will check if it can fire, if there's an enemy somewhere nearby, and if it is, it will fire at it, execute an attack, and then it will continue walking for 3 seconds, and so on and so forth. The only thing that you have to check here that this is not patrol endlessly, because this task will finish after flipping. So what we want to do here to make it truly endlessly is the repeat task here, and it should be repeating the whole sequence. Okay, now it's truly patrolling endlessly. So let me now modify the behavior that this enemy has, and this bug with gun, and it's called patrol and attack. As you can see, I'm doing very high level naming because, well, I don't want to have a bug with the gun AI, because we can reuse the same kind of stuff, the same kind of behavior for other enemies that have the attacks, and it's just the definition of the actual entity, like in what way it's attacking, whether it's projectile, what projectile is it, where to spawn it, or maybe it's going to be a melee attack, and so on. So this is a very good approach to behaviors to make them as general as possible, and like move ourselves away from the very specific stuff about how it attacks. So we just have a fire at enemy, or maybe I should rename it at attack enemy. Yeah, probably should be, but I'll rename it in a moment. So let's see how it works, if it works. One, 2, 3. Come on, fire. 1, 2, 3, fire. Okay. It's firing, however, it's firing always appears. No. Okay, so it's wrong direction. Okay, but overall it indeed fires. As I said before, it was checking whether there is an enemy in anywhere. That's why it's firing here. Okay, so the missiles are at the moment not moving. This is something that probably add later on as the episode is getting very long. So let me fix 2 things. So I'll rename this to attack enemy, and here I have to import attack enemy. And another thing I want to change is the way the combat system is spawning it. If it's turning left, then the distance, let me take a look at this, 0.5. So if it's turning left, then it should be minus 0.5. But definitely we want to here also have that if the projectile has component facing direction, then it should copy the direction from the enemy itself. Not enemy, sorry, the entity direction. So from the bug, in this case. Did I not check what it was doing here? Yeah, this was the bug. I didn't have the if here, I believe. I'll have to review the video later on, but I think I didn't have the if here. That's why it was spawning. So let's test these two changes. So the renaming and this whole facing stuff. Two, three. Okay, spawn in front of it, in front. Okay, so I think that helped. The location of this is incorrect. I have to modify the projectile, translate Y. And it's gonna be minus 0.25 as well, I believe. Let me check that. I want the projectile to be actually like going out of the exhaust of the gun that this guy is carrying. Yes, okay, that looks better. So what we need now is two things. First of all, this projectile, of course, should be moving. And second of all, we want, because at the moment, if the projectile hits the player will die, obviously. However, what we want, another thing is that you can imagine the projectile it's going to be going forever to the left. We want to despawn it at some point. So we can do it in two ways. We either can say that something that's also gonna be dying when it gets off out of the bounds of the level, or alternatively, we can make it disappear based on time, so it basically dissipates over time. I think I'll go for the other option, and so in the attacks projectile component, I'll specify the time. Dissipate duration. Okay, and this is something that I'll introduce a new concept, which is the delaying some actions. So for that, I'll need delay manager, another class from the gaming package, gaming module. I have to enable it in the gaming profiles. And in here, we can add a delayed action on the projectile and say that we want to dissipate projectile, and delay is going to be coming from here, and in the projectile sorry, no, not here. In here we'll specify dissipate, what was the duration? And let's say that we want to disappear after 3 seconds. So in here, we want to, this delay manager on this entity invoke this action after this time. So the way we receive notification about this is using the receive event that the time has passed. And the name of the event is delayed action triggered. And we have to check that the action ID is actually the one that we wanted, because there might be different actions invoked on the same entity, and we want to make sure that this is the one that we actually are interested in is invoked here. And if so, we want to entity manager destroy entity. So let's run it now and see if the missile is projectiles indeed gonna disappear after I think it was 3 seconds I configured it to. Yes, 3 seconds. Let's take a look at this. One, 2, 3, gone. Okay. So now what's left is making them move. But this will have to wait for the next episode, as this one is a pretty long one. Okay, so I'm really sorry for the long episode, but it was like very complicated stuff here. Make sure to like this episode, subscribe to my channel. Thanks for watching, and bye.